So other forms of measurement is instead of measuring just distance and weight, mass, and volume or capacity, other things we measure is time, temperature, and there's also these other measures we'll kind of throw at you here in a little bit. Time and temperature. Time is pretty much a universal. I mean, hours and minutes are pretty much what everybody uses. There's no other unit of time in the world. Is we just basically use hours and minutes for the most part to keep time. So remember that 1 hour is equal to 60 minutes. That's our conversion factor. And 1 minute is equal to 60 seconds is our conversion factor if we need to do any conversions. So with respect to time, let's look at this example. Suppose we have 1 hour meeting and 5 items to be covered on our agenda. If we devote the same amount of time to each item, how much time should we give to each item? So we have this 1 hour, but we're dividing it into 5 equal times. So this becomes then like 1/5 of an hour. So I have to devote 1/5 hour to each item. But what's a fifth of an hour? It doesn't really ring out to me how much time I need to spend. So it only makes sense if I convert the hours to minutes. So we can do that by using our conversion factor. So remember, if our original unit is hour, the hour's got to be on the denominator over here. And what we're converting to is going to be on the top, which is going to be minutes. And our unit ratio is going to be 60 minutes per 1 hour. So by doing this, the hours will actually divide out, and that leaves me with my minutes. So 1 times 60 would be 60. 5 times 1 would be 5. This is going to be 65ths hours. I'm sorry, 65ths minutes. But remember, 5 does go into 60. That's divisible. That's going to be 12 minutes is what we'd have to spend on each item. So that makes better sense. 1/5 of an hour, I don't know, but 12 minutes, yeah, I understand what 12 minutes is, and I can almost mentally pace myself on 12 minutes. Now, when it comes to temperature, there are 2 ways temperature is measured. Fahrenheit is more of a customary measure, and Celsius is more of what we call the metric way of measuring temperature. To do temperature, we actually have these 2 formulas that we use to convert from one temperature unit to the other. So if I want to convert Celsius to degrees, I need to make note of this formula. And usually I like to use the one that's got the decimal. F equals 1/8 degrees Celsius plus 32. Then I'd go straight to calculator. But, one thing that's also important to understand is, what does temperature mean to us? Well, for us, when it comes to temperature, 32 degrees Fahrenheit is important for us to know. 9 degrees Fahrenheit is kind of important. And then the 212 degrees Fahrenheit become important. So, 30 degrees Fahrenheit, why it's important, it's all about water. That's when water turns to ice. And when it comes to plants, ice is kind of a killer to plants. It'll kind of freeze them and kill them. So temperatures dropping below freezing is a dangerous thing for our fruit and our vegetables. So if you ever follow that with Florida and things like that, they always talk about freeze warnings with oranges and things like that. And the whole orange crop is wiped out because of the temperatures. So 32 degrees is very important. And what's nice is as Celsius, it's actually 0 degrees Celsius is the same thing as 32 degrees Fahrenheit. That's when water will freeze. Now, the other one is, water from its liquid form can turn into a what we call a vapor or evaporation, if you will, at 212 degrees Fahrenheit. So 212 degrees Fahrenheit is when water will boil. In other words, it turns to steam, turns into a different state. And that's going to be 100 degrees Celsius. So 0 degrees Celsius is when water freezes. 100 degrees Celsius is when water boils. Okay. And then 9 degrees Fahrenheit would be, a warm summer day. And notice that 32 degrees Celsius would be also considered a warm, sunny day. Okay. So keep that in mind. 32 degrees Fahrenheit, that's freezing. But 32 degrees Celsius is actually a pleasantly warm summer day. So keep that in mind as we use that as a reference. So as we move into the problems, if I want to use the formula to verify 212 degrees Fahrenheit, the boiling point of water is equivalent to 100 degrees Celsius, what I can do is use this first formula, F equals 9/5 degrees Celsius plus 32. Doesn't really matter which formula you use. So the formula would look like this. Or I could also use 1.8 times the degrees Celsius plus 32. So if I change Celsius to 100 degrees, this becomes then 1.8 times 100 plus 32. And notice that 1.8 times 100 would just be 180. 180 plus 32 would be 212. So that's verifying that 100 degrees Celsius is the same thing as 212 degrees Fahrenheit by using that formula. Now, as an application, according to Dr. Wembley, an antifungal powder containing tofulconate, don't have a clue how to say that, may be stored at room temperature of 77 degrees Fahrenheit. Change 77 degrees Fahrenheit to Celsius. Now, again, if I'm using an estimate, I know that 77 degrees Fahrenheit would be somewhere up in this area, which means it's got to be below 32 degrees Celsius. It's got to be above 0 degrees Celsius, but it's got to be probably closer to 32 degrees Celsius. So that's what we're looking for, is the temperature somewhere below 32. So as an estimate, 77 degrees Fahrenheit, I would say it's probably in the 20 degrees Celsius range. Now, the way we do this, though, is we're changing Fahrenheit to Celsius. That's the second formula. To convert Fahrenheit to Celsius, we use the formula 5/9 times F minus 32. So Celsius is going to equal 5/9 times the Fahrenheit temperature plus 32. Make sure I wrote that right. Nope, minus 32. See, I haven't memorized my formulas yet either. So minus 32. So in doing this, I have this 5/9, and the degrees Fahrenheit was now 77. We want to take away that 32. So 77 take away 32, I could do that. That's going to be like, what, 40, 45? So it's going to be 5/9 times 45. I can make that 45 over 1. And notice how the 9 does divide into the 45 in 5 times. And 5 times 5 is 45. So I don't really have to use my calculator. So C would equal then this 25. So in other words, 25 degrees Celsius. And that's pretty much where I was anticipating the temperature to be based on my estimation. So 0 degrees Celsius is 32 degrees Fahrenheit. And 32 degrees Celsius is like 90 degrees Fahrenheit. So those are kind of useful in making estimations. So as we move into some other areas, the international measurements here, you may come across some of these in your world of trying to find a job out there. You may have to work with meters or kilograms or liters or seconds. That's how we have these different units of measurement. A lot of times in science, we have Kelvin as well. That's another form of temperature. Most commonly, what we deal with Fahrenheit and Celsius, but if you're getting into science, Kelvin becomes really important, especially when we talk about like the temperature of the sun and things like that, or something that's really, really cold. We get into these kelvins. Ampere, you get electricity, we have amps, there's light intensity, which is the candela, the mole, Newton, joule, all these are kind of familiar. Volts and ohms are probably familiar to you. Henry may be even familiar to you, and Coulomb. So these are a lot of these are just universal. You don't have to worry about dealing with other countries and doing conversions. Everybody's going to deal with these the same way. They mean the same thing. Another thing we come across is what's called the BMI, which is called the BOS, body mass index. A lot of times athletes use this to kind of get an idea of body fat, if you will, how healthy they are with respect to body fat. Anyway, when it comes to BMI, notice how things have to be in kilograms, and we have to have meters, things like that. So we have to convert pounds to kilograms, and we have to convert inches to meters. So what happens is we have to move into this next section, which is customary metric conversions. So this is where I don't have this memorized. I have to have a table, and I will have this table. You'll be able to access these tables in a Blackboard. I'll lay those out for you so that you'll have these tables, so you don't have to go trying to track everywhere to get these. And if you're in class, I'll hand out a copy of these tables for you, so you don't have to go looking for them. Notice how we do have conversions: meters and inches, meters and feet, meters and yards, centimeters and inches, millimeters and inches, kilometers and miles. We have grams and ounces, kilograms and pounds, liters and quarts. So we have all these different conversions that we can do. So if we know what we're doing, we have these special conversion factors that we can use over here as a shortcut. So we just use what's called a conversion factor. If we know if we're going from big to small, or small to big, or whatever, or we can use these conversion factors. So if I want to change 50 feet to meters, so we got to go feet to meters. Looks like this feet to meters is this one right here. So the conversion factor would be this 0.3048. So, all we got to do is multiply 50 times then this 0.3058. I have to double check myself. Feet to meters, 0.3048. Didn't remember it, did I? I'm still working on that. I'll get better. So if I multiply 50 times 0.3048, I'll probably just use the calculator for that. 50 times 0.3048, that gives me 15.24. So 15.24 meters. So remember, we had a prefix table up there as well to remember to pick up on. Instead of spelling out meters, we can use the prefixes. So another thing we have, how many full cups are in 2 liters of a soft drink bottle? So if you have a 2-liter soft drink bottle, how many full cups are actually there? Remember, a cup was like 8 fluid ounces as well. So we're trying to convert cups to liters or liters to cups. So we're looking for cups. So we want to convert liters to cups. We have liters to quarts. And that's all we have. So all we're allowed to do here is convert liters to quarts to start with. And then we'll have to take it from there. So we have 2 liters, but all we're able to do with our conversion things is convert it to quarts. We're going from, liters to quarts. So 1.0567. So 1.0567. So if I do that, I'm going to be in the form of quarts. So we get 2.1134. So then I still got to convert quarts to cups. So remember, with gallon man, there's 4 C's for each Q. So I know that I have that 4 Q's per gallon per cup. So since I'm converting to cups, we have 4 cups per 1 quart. So that's how my quarts are going to divide out. So if I multiply 2.1134 times 4, so if we just multiply that by 4, we get 8.4536. So we have 8 point, then cross myself up, 4536. So how many full cups? When I round, I can't round up because I'm talking about full. So I can't have what I don't have. So we have to use then just the 8. So this becomes then 8 cups. So 2 liters is going to give me actually 8 cups. Okay. So that's like, makes sense there. If you think about that. If I have a 2-liter thing and I pour that out, 8 cups sounds reasonable for that. Okay. So that's how we actually can do some conversions, but notice how once we get to customary, we still got to do some more customary conversions. So we have to have all of that. So the last topic we're going to get into is called significant digits. So I'll play this out in the next video.